For an immense span of time, Earth was their kingdom. The dinosaurs, magnificent creatures, great and small. They roamed every continent. They swam in the vast oceans. They even flew through the ancient skies. For over 150 million years, they thrived. Imagine such a long, unbroken reign. A true dynasty of life. Their world was vibrant, full of their forms. Then quite suddenly, in geological terms, they vanished. The mighty Tyrannosaurus rex gone. The gentle, long-necked Brachiosaurus no more. The skies, once filled with pterosaurs, fell silent. It was an extraordinary extinction, a profound mystery that has puzzled us for generations. How could such dominant animals disappear? What colossal event could erase them from our planet? This question echoes through the halls of science. Early discoverers of their giant bones were baffled. What could have caused such a widespread demise? Some imagined great floods like in ancient myths. Others thought perhaps a sudden deadly plague, or maybe the climate changed too drastically for them. Many theories were proposed, some fantastical. None seemed to fully explain the sheer scale. Today, one explanation stands out. It is a dramatic, almost unbelievable tale. The story of a visitor from outer space, a colossal asteroid, a rock kilometers wide, hurtling through the darkness of space, on a collision course with Earth. Imagine a mountain, 10 kilometers across, flying faster than any bullet. This was the harbinger of doom, a truly terrifying prospect for any life below. This giant space rock struck our planet. It happened about 66 million years ago. The impact site is in modern-day Mexico, near a town called Chicxulub, in the Yucatan Peninsula. The energy released was staggering, 1 billion times stronger than an atomic bomb. Can you picture such an explosion? The Earth itself must have shuddered. A moment that changed the world forever. The immediate effects were catastrophic. A brilliant flash, brighter than 1,000 suns. Vast earthquakes, shaking continents. Giant tsunamis, racing across oceans. Waves hundreds of meters high, swamping coastlines. The air itself became superheated, incinerating everything for hundreds of kilometers around. The colossal impact threw unimaginable amounts of material. Dust, rock, and soot were blasted high into the atmosphere. This debris spread rapidly around the globe, forming a thick, dark shroud. It enveloped the entire planet. Sunlight could no longer reach the surface. The days grew dim, then almost completely dark. Earth was plunged into a prolonged twilight. A chilling, sunless period had begun. The sky itself seemed to weep dust, with the sun's warmth and light blocked. Photosynthesis, the basis of most life, faltered. Plants on land could not make food, they withered and died in their billions. In the oceans, phytoplankton, tiny plant-like organisms, also perished. These formed the very bottom of the food chain. When they disappeared, the chain began to collapse. Herbivores, the plant eaters, faced starvation. There was simply nothing left for them to eat. A silent, creeping famine spread across the land. As the darkness persisted, temperatures plummeted. The planet experienced a sudden, drastic cooling. This is what scientists call an impact winter. It was like a nuclear winter but caused by nature. Freezing conditions gripped much of the Earth. Even tropical regions became cold and harsh. While the asteroid impact was undoubtedly devastating, it might not have been the only factor. Some scientists believe Earth was already in trouble. The dinosaurs' world was perhaps already stressed before that fateful rock arrived from space. Other natural calamities were unfolding, creating a more vulnerable planet, making life difficult for many species. Around the same time, geologically speaking, there were enormous volcanic eruptions on a scale rarely seen in Earth's history. In a region now known as the Deccan Traps, located in modern-day India, vast floods of lava poured out, covering huge areas of land. These eruptions continued for thousands of years, releasing immense quantities of gases and fundamentally altering the environment. The asteroid could have been the final, terrible blow to an already weakening world. This combination of disasters could explain the totality of the extinction. How do we know all of this? Scientists act like detectives of deep time. They search for clues buried within Earth's crust. The rocks are like pages in our planet's history book. Each layer tells a story of a different era. Careful study reveals past environments and the life that inhabited them. Fossils are the most direct evidence, of course, but the rocks themselves hold vital secrets. One of the most important clues is known as the KPG boundary. It stands for the Cretaceous-Paleogene boundary. This is a thin layer of clay found in sedimentary rocks all over the world. It marks a very specific moment in time, the exact point when the Cretaceous period ended and the Paleogene period began, 66 million years ago. Below this layer, dinosaur fossils are abundant. Above this layer, they are almost entirely absent. However, the story doesn't end with complete devastation. Life, as it so often does, found a way. Some species remarkably managed to survive. These survivors became the ancestors of future life. Their resilience is a testament to life's tenacity. Who were these fortunate survivors? Generally, smaller animals had a better chance. Our distant mammalian ancestors were among them. Birds also survived. We now know birds are living dinosaurs, descendants of small feathered theropods. Amphibians like frogs and salamanders made it through, as did many insects, fish, and reptiles like turtles and crocodiles. Why did they survive when the mighty dinosaurs did not? Several factors likely played a role. Being small meant needing less food. An ability to hibernate or reduce activity helped. Living in burrows or in water offered shelter from the initial heat blast and the subsequent cold. A varied diet was also an advantage. Creatures that could eat seeds, insects, or decaying matter fared better than those reliant on fresh plants or large prey, which had disappeared. The extinction of the non-avian dinosaurs was a profound tragedy for them, but it also created an extraordinary opportunity for those species that survived. This mass extinction truly reshaped the future of life on Earth.